Hi guys and welcome. For a while now I've been thinking of a wee modification, or addition I should say, to my hybrid machine, and so I've started gathering parts for it, and I'm just putting together this video so that to show you basically what I'm planning on doing, and to see if anybody has any suggestions on how I might improve it, or maybe my ideas just aren't good at all. So I'll basically value your input. What I want to do is I want to add this to my machine. This is a laser unit. It's a blue laser, it's just a diode. It's 1.4 watts, so it's a class 4 laser, so potentially dangerous. And basically what I want to show you is the setup I propose in an attempt to add safety to this, and yeah, like I said, I'd value your input on what I'm doing here. Right, so let's have a look at the what I plan to do. Right, so starting at looking at the bits that I've got so far for this project, I've got the laser. Now this has a focusing distance of 1 to 5 inches. This laser is blue in colour, and I'll explain why I've picked on that. When I looked at lasers, I had 3 options. I could go red, but the red was only 300 milliwatts. It probably would have done what I wanted, but I thought I'll go a bit more powerful. This is 1.4 watt. I could have gone a 2 watt infrared, and it was actually a bit cheaper than this. But the reason I didn't pick the infrared was because I can't see it. And this one, at least I can see blue, and if there is light spillage, or I'm more likely to see something going wrong with this than I will if I'm using infrared. Infrared, you can't see it. I'd be able to see it with a video camera, but that's about it. And at least the blue, it's a constant reminder. If you can see it, it's a constant reminder that it's on, that you can see things. If there are reflections and things, you'll be able to instantly see that. With infrared, you don't get that option. It's out of the visible spectrum, and so I picked blue because it will give me a bit of warning. I've tested it just on a piece of MDF. Just drew a piece of MDF past the beam, and it cut me a nice thin line, and it did it very quickly too. So this should do what I require. What I did find though is that blue apparently has a squarish shaped dot, whereas infrared I believe is quite round in shape. But I don't think that's going to matter. I've seen quite a few YouTube videos where they've used the blue laser, and it seems to work quite well for what I want. Now I should explain, I'm not trying to cut anything with it. I just want to use it for engraving. I thought it would be a great enhancement and easier than using Photo VCarve for certain things. If I want to do lettering or photo, try engraving photos on wood, it should make life a lot easier. Now to this I've added a couple of extra things. One, these are a must. Basically, laser glasses. These are certified. They've got their certification written on the lenses themselves, and I picked them up from a reputable seller, not from a Chinese one. And they have an optical density of 7, which is quite high. They're 7 at the frequency range of my laser, which is 445 megahertz. So, oh sorry, wavelength of 445. Sorry. Right. Now I've added a few extra bits and pieces. I want to have a key switch so nobody can wander in and just turn the thing on. So that's a safety, another aspect of safety that I want to do. I want to make sure that nobody can just wander in and just switch the thing on. Now, I believe that's actually a requirement for Class 4 lasers as well. So I like that idea. Now, just in case, because the key comes out of this, it's a possibility that I may accidentally turn it on, go and turn the machine off, wander inside, come back, turn it back on again. I don't want the thing just starting up by itself. So to that I'm going to add the switch. This is only a push to make switch. So basically the key has to be turned on and this button has to be pushed, because this button will latch on this relay. So when the button's pushed, that key's on, the relay will latch and turn on the laser. So that's just an added piece of safety. Now, to make sure that nobody comes along and picks up the unit and decides that, oh, I'll have a look at it, the mounting for that is going to include one of these. These are a Mercury Switch. So basically, as soon as the thing's in this position here, it will switch off. If it's no longer pointing down, if it's tilted, it'll turn off. So again, basically it'll unlatch the relay will just fall back, the laser will be turned off, and it will not restart until the button's pushed again. So it's just a little added safety feature that I wanted to add to it. Now, my biggest concern with this is all the YouTube videos I've seen of people who add lasers to CNC machines is that they just take the laser and they mount it somewhere on their Z-axis. They take off the router and they mount it there. And you've got all this exposed beam here, and then you've got all the resultant reflections as well. And I want to eliminate that, because that's sort of my greatest fear. So also on my machine, because of the way I've got it mounted and I've got all these extra cables, it's all cable tied in, I've got my Super PID. Removing the router isn't really an option. It would be no problem for me to quickly mount it there. I could get away with that easily, but I've come up with a better idea. What I've made is this. A bit strange, you might say, and you'd be right on that score. This is only part of it. This here clamping arrangement is designed to slide up onto the router itself and clamp around it. So that's going to give me a mounting point here for the laser. The laser will sit like so on here. It's been hollowed out in the center, and there's actually another piece to go on top. This piece here will mount on top like that. So basically the unit will look like this. The hole goes straight through the center, so the laser going down through there will come out the bottom. There's a pocket here for the router collet to sit in and spin in. If by chance the router accidentally gets turned on, it's not going to cause any problems. Now this is going to solve several issues for me. So I'll quickly screw it together and we'll take another look at it in detail. Now, this large flat surface here is going to be painted matte black, and you'll see why in a minute. And I've actually built it wrong. This here should actually extend out here. There should be an even, it should be the same distance from this hole all the way around, and that's to provide me some shielding. So I'll just move the machine up here. I'll bring it forward a bit. Okay, this here will mount on here like so. Right, so that's it in place. It'll have a screw in there to hold it, and this here I have yet to mount properly. I'm going to put a piece of angle aluminium in here to clamp that down, and it'll be held straight down. Now the on-off key and thing will mount somewhere around this area here. I haven't decided where. And as I said before, the final model, it'll actually extend out here the same distance it does from the centre of that hole to the sides. It'll extend out this far at the front. If we imagine this is the piece of wood we wish to engrave along here, the aim of the exercise is that this here will come down and sit just 3mm above the material. Now I can easily get the height I require by simply pulling the machine forward to here. Basically just take it down here until it's sitting on top of it. Set that to 0. And then bring the router up 3mm like so. I'm now 3mm above my material I wish to engrave. And we can get on, and the next part becomes aligning with where we want to put our thing. So what I would do is I would put a small mark on my material, say there is where I wanted to make my the center of my engraving. I can then pull the router forward, and on this point here I'll have a wee mark. I can line that up until it's say center there. So I've got my little mark here on my thing there, and I know, okay, I'm now X0. Next I can then come along here and do the same on the side. Here I might have a mark there, say, so I can simply align it there, and now I'm at Y0. And that's the simplest way I've come up with aligning the laser to my material. That way I don't need to put in special laser guides, or I don't need to lift it up and point the laser down and look at the thing. Not interested in that. And yes, that's my alignment procedure. Now the other thing you'll notice is I'm very, very close to the material I'm cutting. I intend to focus the laser so that it's 3mm below the shield. And the aim of the exercise here is I've got this far, well, it'll actually be about this far from my shield in any direction, and I'm hoping that will stop any reflections. It's going to have to bounce multiple times. Remember, the bottom of this is going to be black, so to absorb any light and not reflect it. The only danger I should be from is a laser reflected straight out this very small gap here. That would make it at testicle height, so I'll be very, very careful. One advantage of putting this unit onto the router is it gets rid of another issue that I was having with the design. Obviously when I'm engraving something with this here, there's going to be smoke created, and the last thing I want is smoke drifting up and getting on to the lens of the laser. So another reason I put it on my router is because I need the source of air to blow out the bottom to keep the smoke away from the laser lens. So I'll just quickly turn on. Luckily my router has external fans here, and so I'm going to be able to use those. But if I had a standard router, I would simply turn the thing on like so, and the fan built into the router would provide the air. And that's the reason for that channeling you saw in the original design, in the layout. Here it is, fans running, and there's a whole lot of air coming out of this hole here. It's just pouring out. So that will obviously be blocked there, but now the air is just pouring out the hole in the bottom there where the laser was, so I can feel air everywhere here. So that's going to push the smoke out from the wood. It's going to keep the laser lens clean. Hopefully it it doesn't blow cold air onto where it's engraving and start a fire. That could be an issue. Again, I don't know. I don't think it will. It may also be quite helpful if I try doing small plastics. I have heard, and again I don't know, that air assisted, using air to assist a laser in cutting through thin materials, so that may perhaps be an assistance as well. That's my plan basically. I'm hoping this shielding arrangement will provide the protection I require over and above the glasses, both for me and for anybody else who might inadvertently come in contact with it. I also intend other safety measures. I've got windows on the garage here. They're going to be blocked off with plywood or MDF so they can't be seen. And the door, I'll keep the door locked basically, so that nobody can come in while I'm doing this. So basically this is my plan as it stands, and I'm open to any suggestions on how I could improve it. I'm first to admit I don't know a lot about lasers and the effects of laser light, and I welcome any suggestions that anybody has, any improvements or anything you see that I've missed in my design so far. Well, that's it guys, and I hope to hear from you guys. Cheers.